Now let's proceed to the properties of segment notation. It is very useful to solve efficiently some of the shorthand or segment notation problems. Okay, for number one, the summation of I from I equals 1 to n, that is also equal to n times n plus 1 all over 2. Remember that in our arithmetic series, we have a formula n times a sub 1 plus a sub n over 2. Here, in our first property, that's also almost the same with the summation of I from I equals 1 to n. That's 1 plus 2 plus 3 and so on until n. So it's equal to n times n plus 1 all over 2. To our, it's like on our multiplication table where here is the n and here is the n plus 1 together. That is the total numbers of n, and let's divide it by 2, so that's also equal to the white dots or the black dots, and that's the answer. Okay, so let's apply the first property of sigma notation. Number 1, add the summation of I from I equals 1 to 5. Using this formula, our n is equal to 5, so n times n plus 1 over 2, that's 5 times 6, that's 30 over 2, so it's equal to 15. Number 2, the summation of I from I equals 1 to 25. Our n here is 25, so 25 times 25 plus 1, that's 25 times 26, divided by 2, that's 325. Remember that we can only use this property if it is if the index starts at 1. Other than that, we cannot use this property to this one. Another property is the summation of c times f of I from I equals m to n is equal to c times the summation of f of I from I equals m to n, where c is any real numbers. Okay, so let's start. So the summation of 5i from I equals 1 to 5. So that's this one. Let's apply this. So we separate the constant. So here, 5 times the summation of I from I equals 1 to 5. Okay, so this form is familiar because it is on our first property. We will apply the first property where n is equal to 5. So 5 times 5 times 5 plus 1, that's 6 plus 6 times 5, that's 30, divide 2, that's 15. So 5 times 15 is equal to 75. That's for the second property. Okay, another property, the summation of c from I equals m to n is equal to c times n minus 5 plus 1, or the summation of c from I equals 1 to n is equal to c times n. Let's apply that. The summation of 5 from I equals of 5 to 25. So again, c is constant here, so the 5 times the index is 5 here, starts at 5 and the end is 25. So 25 minus 5 plus 1, that's 21. So 5 times 21 is equal to 105. Another example, the summation of 5 from I equals 1 to 25. We could use the second, which is it started at index is equal to 1, which is similar to the problem. So just multiply the constant and the number of the upper bound. So 5 times n, which is 25, is equal to 125. Next property, The summation of f of I plus g of I as I from I equals m to n is equal to the summation of f of I from I equals m to n plus the summation of g of I from I equals m to n. Example, if our f of I is equal to 100 and the g of I is equal to 50, what is the value of the summation of f of I plus g of I from I equals 1 to 5? Now, applying the previous sigma notation or properties of sigma notation, the summation of f of I, which is equal to 100, this is a constant, and I is equal to 1, so we could multiply the constant times the upper bound. So 100 times 5, that's 500. Okay, for g of I, that's 50, so the summation of 50 times from I equals 1 to 5. Now again, this is also, we could also use one of the properties of sigma notation we have learned previously. So our index starts at 1, so since this is constant, multiply 50 to the upper bound. So 50 times n, or 5, that's 250. Together, we will add the terms of 500 plus 250, that's 750. The same thing happened here. The summation of f of I minus g of I from I equals 1 to 5. So, the f of I is 100. So, the summation of 100 from I equals 1 to 5. Again, I is equal to 1. So, the index starts at 1. And since this is constant, we will multiply it to the upper bound or the end. So, 500 times 5 is 500. Next thing, the summation of 50 from I equals 1 to m. So this is a constant started at 1. So 50 times 5, that's 250. So 500 minus 250 is equal to 250. Okay, next property. The summation of I squared from I equals 1 to n is equal to n times n plus 1 times 2n plus 1 all over 6. We will use this one to our example here. The summation of k squared from k equals 1 to 12. So we will use this formula. 12 times 12 plus 1, so 12 times 13. 2 times 12, that's 24 plus 1, 25 all over 6. So 12 times 13 times 25 all over 6, that's 650.